right, everybody, welcome to Playing with Memory, presented by my friend and colleague Kyle Andrews. I'll let him get started right after this joke in the tradition of Kyle speaking. Why do turtles make such good hackers?
They know something about shells.
I was going to say, they bring their own shells. Very good. All yours, Kyle.
Well done. That was beautiful. Hello. Good morning. Afternoon. Oh. My name is Kyle, as was announced. A little background about me. Working in IT for a while. I really focused in endpoint security like the last four. So I work for a Fortune 500 energy company that's in this state. There's only like 2, so good luck. And so my job right now is I'm on a cybersecurity and incident response team. So I'll do anything from digital forensics, HR compliance investigations, to jumping into possible malware samples or looking at phishing emails or attachments and things that people dropped. And so my main goal is always to try and answer questions around, okay, was it bad? What happened? Where did it come from? Try and generate some indications of compromise that we can use later to search the rest of our network. I also help coordinate for MySec. So MySec, like Jackson, Lansing area is usually where I'm at. I live in Lansing itself. And I'm also a Converge Bsides organizer. So I might be a little rough up here because I've gotten like an hour of sleep every other night. And I've been walking these halls back and forth for the last 3 days. So if I zone out or like stumble, you're allowed to throw things at me. Anything that'll make an impact, that'll help me. Thank you. So the only thing I'll mention, if you're not familiar with forensics at all, you might hear me say artifact a lot. And in computer forensics, it's really just a digital piece of evidence that's helping you prove what you're going after. Like a browser history or even like a simple file somewhere. It's a very general term used in the forensics community. One thing that I would recommend if you want to start playing around in forensics is the SIFT workstation. It's a free workstation you can get from SANS, who does a lot of security training. And SIFT is just it's just chock full of different tools that you could use from anywhere from memory to even like disk analysis. So it's a great tool to have in your bag. Talking about just acquiring memory. So you have a machine. So what do you do next? You want to actually pull down a copy of the memory so that you can start doing some type of analysis with it. There's a lot of tools out there. Dump It was like one of the easiest ones that you can find and use. I don't know if it's still currently working with some of the newer operating systems, but it was very popular. And it was as simple as you just ran dumpit.exe and it dumped memory directly into the same directory that you ran it from. And then a newer one that's been out there, magnetic RAM capture from Magnetic Forensics. It's a great tool, very quick. One of the advantages of it is that you can actually run it from the command line as well. So when I started acquiring memory or doing investigations, I started off by you'd have to go to the machine or log in and then, grab memory. And then my next step was I learned about like Redline. Redline's another memory analyst kind of framework. It's got a lot of other issues I don't want to talk about, but one thing that I did use it for was you could make Redline collectors, and that's basically just a batch script that this tool would spit out. And the batch script you could just send to another machine. So if you have admin rights, you could use something like xcopy and a UNC path to copy it from your machine to a remote target, and then you could remotely use something like psexec to kick it off. So then you could capture memory remotely and then pull it back. So that was what I used at the time. And then as we've gotten more mature in our organization, we've bought some more commercial products that really help us out to automate some of that stuff. But there is a lot of stuff out there that you can use for free. FTK Imager is another good one to have in your toolbox. It allows you to capture memory, and also it allows you to like mount images. So if you had a raw like a disk image or something like that, you can mount it and take a look at it. You can also run it on just your normal hard drive. So if you deleted files in your drive, it can actually help you recover some of those files if they're still there. So just good free tool. So then you capture memory. Oh, nobody's had it? All right. So then a couple of things that you might want to grab that are pretty useful. One would be the hibernation file. So if you're familiar with Windows systems, when you put your machine to sleep, it creates a hibernation file, which is kind of like a direct copy of memory on your disk. This is really useful because you can actually use a quick tool from Volatility to turn that hyperfill.sys file into a regular memory image that you can play with. So it's kind of like you can get 2 memory images from a machine each time that you visit it. You can run a tool and collect what's currently running, and you can grab a copy that would be sitting in the hyperfill file. And you can find out, it's been very useful before where, they may have done something and then put the machine to sleep, and they came back on later, and what was previously in memory got washed out, but it was still in the hyperfill. And with many of the VMware infrastructures, you can usually just copy like their .vm file, and that in itself is their running memory. So, and then the page file.sys. So, everybody familiar with memory and how files get paged in and out based on how much memory is in use? So Windows has their paging file where if you're not using something in memory, they want to free that up as much as possible. So they'll page unneeded things down to the disk and then pull them back up as needed. It's incredible what I can find from the page file. People go into incognito browsing, or they wipe their history after they're done, and they do all types of fun stuff like that. They don't realize that a lot of that stuff still gets paged in the background to the page file. I pulled up internet history on an individual that went back 2 years. So it's very useful to grab. So then Volatility in general, if you're not familiar with it, is a framework for basically diving into a memory image. They have a very large community. They have a lot of different plugins that you can use, and it's constantly being developed. And it works with Windows, Linux, Mac OS, and I think there's even more out there. So very active community. So when using Volatility, probably one of the first things that's kind of tricky is when you have your memory image. For example, this one is a stuxnet.vm. You need to have a profile that'll tell Volatility how to properly parse through all the memory structures of the operating system, so that way you can use the plugins correctly. So in this case, you run a command called image_info, which will give you information as to what profile you should use with this memory image. And so you'll notice down here I've highlighted the image type Service Pack 3. So basically this is XP running Service Pack 3, and we have up here Windows XP SP3. So that would be the profile that we'd use. Other notable things is we have this thing, this memory address right here for the kernel debugger data block. This is pretty useful for a variety of the plugins. Sometimes you need it, sometimes you don't. But it's good to know that that's where you can find it from image_info. And that's where PSList is also pretty important. So a couple of your first plugins that you'll get very comfortable with is to just view processes. It's going to be like PSList, PS3, PSScan, and PSXView. PSList essentially gives you an output like if you were in Task Manager on a Windows system. It shows all the running processes. PSList does that by taking that KDBG file or memory address that we found before, which is a debugging structure in memory, which has a pointer that goes to this another structure called an eProcess block. This structure is kind of like a doubly linked list that keeps every single process that was running on the system. And so it just traverses that doubly linked list and prints out all the processes that were running at the time. And PS-tree just has a nice, it's the exact same thing as PSList, just gives you a tree view. PSScan, on the other hand, doesn't look at the kernel debugger block or any of that, or the process block. It actually has a pool scanner that will go through the memory image from top to bottom, looking for any of those eProcess structures. And then it'll print them out. So if someone, for example, was trying to hide their process on the operating system, they could remove it out of that eProcess doubly linked list, and you go to Task Manager and it wouldn't be there. It would also not be there in PSList. But if you did PSScan, it would show up. And PSXView is kind of like a combination of everything. It'll give you this graph this little table that shows you, everything it found in PS List, everything it found in PS Scan, and a variety of other tools. So it's very useful, but it can also take a lot of time. A quick example of how this can be useful just looking at PS List. A lot of processes or malicious processes like to hide in plain sight. In this particular case, you can see that we have a bunch of SVC hosts. This first PID is actually going to be the process ID. The second one is going to be its parent ID. So most SVC hosts, if you've seen a Windows system, are actually launched by the service.exe. And you'll notice they all have the same parent ID number, 520, 520. But you'll notice that we do have one down here that's actually misspelled as CV host, and it doesn't come from the same parent. So someone potentially is trying to hide a process from you that you might not see right away, especially when you're looking at this stuff all the time. It can hide from you. But that one in particular is something we might want to investigate. Some more process info. ProcDoc, or ProcDump. If we find a process we're interested in, we could actually just dump it out to disk. This is pretty neat because if you're a reverse engineer and you don't want to go through the steps of trying to unpack an executable and then try and go through statically, if you find the process running in memory, you can dump it, and the only thing that you have to do is fix the input address table or the IAT, and you can basically just throw it into your static debuggers. DLL list is another helpful one. A lot of DLLs get injected into other processes. So if you're hunting around or looking for something that looks weird, both those tools can help you find them and dump them. Git SIDs tell you who's running that process, basically, right? Get the username associated with it. Was it system? Was it the user that ran it? Handles is another useful piece. That's going to be if a process has a resource, for example, access to a file, you can get file paths out of there. You can get registry values that may have been attached to. And mutexes, or mutants, which can be used for kind of identification of either malware or can be unique enough that you could track. And then, of course, NetScan. You can look at processes that are running and what network connections they have. And then some fun ones is ones like Malfind, which does some of that work for you. It'll do some investigation in the background to determine if there's any processes that may have injected code in them. And I'll show you an example later, kind of like what that looks like. And there can be a lot of false positives because injecting code isn't always bad. ImpScan is another useful tool when you see a process in memory and you're just like, I wonder what that does. And what's its purpose? It loaded a bunch of DLLs, but let's see any of the API calls it actually may have made. And so you can use ImpScan to target a process and see if there's anything unique that this process may have been doing. And then some of the fun ones, of course, Mimikatz. If you're familiar with Mimikatz, you can just dump the process or the users, the local passwords that are sitting in the LSAS process. So if there's any users that have logged in, you can usually dump and recover their passwords. Useful if they, for example, have maybe an encrypted volume or something and they use the same password, you could recover that. Hash dump is kind of similar, any cache domain credentials. Auto runs is useful. There's a lot of malware that you can catch with auto runs, actually. Because once a piece of malware infects your system, the next thing it wants to try and do is to continue to run, right? If you just install, you click on something and it downloads and it runs, you reboot your system, it won't come back unless it puts itself somewhere else so that it can basically be persistent. And auto runs is going to give you all these different places where files can be executed from, where they run from startup when you turn the system back on. And then VolShell is a very powerful tool. It's kind of like the debugger in volatility. It allows you to jump into the context of a process and navigate all of its resources on the fly. So let's try and just look at a quick example of this. Give you an idea of what some of these plugins can look like. So in this particular case, we have someone that reported that they clicked on an email address, and your question is, okay, did they actually click on it? Did it run? And maybe something that it could have done. So the first thing we might do is maybe look at PS tree. So we know that they ran, in this particular example, the user clicked on a Microsoft document that was found in a phishing email. So the process we're looking for is winword.exe. So in this case, we have winword.exe right here. But we'll notice something interesting is that winword.exe with a PID of 5084 spawned another process, command.exe. Something that's usually worrying because Word doesn't commonly run commands, PowerShell, and other things. You'll also be worried when you see this from like Outlook.exe spawning things, or even from Chrome or Internet Explorer. So at this point, we're a little concerned about this winword.exe. And then we can also confirm using another command called command line. And command line is going to print off basically everything that ran in the environment. Oh, hold on. Do many people here use sysinternals Process Explorer? So within Process Explorer, you can look at all the processes that are running, and you can see the command line that was used to run that process. And this plugin basically goes through and does a very similar thing. So in this case, if we're confirming if that user actually downloaded or opened up that document, we can see here that it actually says users fills downloads directory, and it's cut off a little bit. But yes, we have a dangerous document there. So next thing we might want to do is let's take it winword.exe and see if it had any network connections. Oh no. No problem. So in this case, we'll run the NetScan plugin. And we're looking for any process IDs of 5084. And we do have them. So we can see winword.exe, and it actually did have an established connection to a local 192.168 address. This happens to be my test environment, because I didn't want to, be safe. That 192.168.200.187 was a Kali Linux machine. And we can see here that it was traveling over 443 as well. So more information to gather in your investigation. Oops. So we did see that the Word document did run command, or it had a command prompt. So there's another plugin we can use called Command Scan. This will basically search for any command line history, and it'll print it out for us. So for us, it did find our PID, but the command line history was kind of blank. There really wasn't much there. But there is another one called councils. And councils is very similar to command scan and volatility, except for councils will also output what was returned from a command. So if they ran like a net command and it failed, you would see the failed command just like if you were running it from the command prompt. So we'll try councils to see if we can see anything from the CMD that was launched. So we don't see a ton like we'd want to, but some things that we do see is we do see a net command that was run. We see an IP config that was run. Information that they may be gathering a little bit of information on that host. So it might have been a little bit of recon. So let's take a look at malfind to see if that can pull up anything else for us. So I'll run malfind, and I'm just going to search for any processes that have a name, any any of the process names that it returns. Is everybody familiar here with grep? Raise your hand. It's a wonderful tool. So like I said, malfind will return a lot of false positives, so not all of this is evil, right? But one thing we can see is that our freaking out. We can see when word did execute. Or I'm sorry, did get picked up in this. So one thing that you can do is just kind of a fast triage is you can take everything, every memory segment that malfind has identified, and you can just dump it to disk. So you can just basically run -d and give it a directory, and it's going to dump there. So I already did this earlier. So if we go into our dump directory, whoops, Windows commands, we can see a lot of the process memory segments that were dumped. And if we use the file command, we can see that some of them were a portable executable. So we could take this file and we could do something like VirusTotal. We could upload that segment to VirusTotal and it'll put it through a whole bunch of AV scanners. The advantage of this is that you can get a quick return and see if potentially if what you're dealing with is malicious or not. The negative part is that you're uploading your data to some cloud place. So that can be dangerous depending on what you're doing. And if you're a malicious attacker and you dropped a payload somewhere and you just uploaded their payload here, they may have scripts running to see, did anyone upload this to VirusTotal yet? But if you're doing like little side jobs, you're playing around at home, this is a great tool to jump into and just kind of get some results back on anything that you may find. You could also build your own type of test environments too, with like a Cuckoo, or there's a bunch out there. But in this case, we did see that it detected it as Meterpreter. So it was definitely a Meterpreter shell that was dropped in this box. So it was a poisoned Microsoft document that allows Meterpreter shells basically allow someone to shell into your machine remotely, which would confirm that we saw those IP configs and net commands. So they definitely were doing a little bit of recon. The last command I ran was the auto runs, which would give us all the locations. It is a very slow plugin, so when you do run it, it takes a lot of time. If we scroll up here, we're going to go through, it'll just show a ton, unless it freezes. Gonna freeze, because that's how live demos work. Yes. Oh, actually, it's at the top. Again, I haven't had much sleep. So, when we're taking a look at this, this first section is actually pushing out some of the hives. And you know in the registry you have, there's a section even for users, ntuser.dat. So this is like your personal registry hive. It collects all your information of like your settings that you save when you log in. It collects information of what programs you run. It also has, whenever you log in, you have all the things that are going to run when you first log in. And so there's the run key in your ntuser.dat. I've seen a lot of malware, when it drops, actually just use the user's own ntuser.dat to be its persistent stage. And in here we have that case. We can see that there is a value added into this person's ntuser.dat and the run key that when they log in next time, it's going to try and run this totally persistent cat, which is basically just running the poison document again. And it would make that connection or that reverse shell back. All right. So let's look a little bit more towards user activity. Browsing history on machines is always very interesting. As an investigator, you go from knowing nothing about someone to knowing too much about them. And it can be kind of scary sometimes, honestly. But there are some pretty cool plugins for volatility. Chrome, Firefox history, and IE. IE is like the coolest browsing history artifact that I love, because it not only keeps, like, you went to IE and for some reason to download Chrome, right? But you went to IE, and it's also, we all know it's tied into the Windows operating system, like, you just can't get it out. And this shows it because it not only logs when you go to different sites via IE, but it also logs when you open things up in your user environment in Explorer.exe, in your GUI. So if you open up your thumb drive and you open up a document, IE records that. It records the path that you opened these files. If you open up documents or pictures or any of that stuff, it all gets logged in the IE history. So you not only get that web history, but you get real activity that the user is doing. Very, very useful. Of course, Chrome and history and Firefox, lots of information there that you can gouge out. Chrome search terms, which is nice because they'll just carve out any Google searches that the person was doing. And those Google searches are what really can tell us a person's intent. I can't tell you how many times I've had investigations where they had all this data, you really couldn't put it together, and then you finally get around to parsing out their Chrome history or just their internet history. And you start seeing Bing and Google searches and how they line up between what they were doing on the system. So it's very powerful. And you can pull it right out of memory. Yeah. And this is a slide that was supposed to be earlier. But the commands I used before, which command scan, consoles, and command line, those three are very powerful for seeing things that were executed. And many times if someone opens up a command shell or they open up a PowerShell, you can actually recover what commands they had at the time. Now, if they close the processes, it's hit and miss whether or not you're going to be able to recover it. So it's kind of up in the air. But if you do catch your memory image at the right time, you can get a ton of data on what they were doing. Some other good artifacts to know about. If you're doing anything in the registry, you have HiveScan, HiveList, HiveDump, and PrintKey. Those all allow you to look for registry hives that are in the memory image, and you can dump them to disk. You're not going to get like a full hive like you would from a hard drive, but you'll get enough data that you could parse it and get some good information from. User Assist is one of those scary things that you don't think about, but Windows keeps track of every program that you run. It'll keep track of this so that it clicks start and it shows like your top, what programs you've run. Yep, it knows that because it keeps in every user's ntuser.dat, that personal Hive file of yours. It's keeping track of how many times you've run those programs and the last time you've ran it. So useful if you're curious, like, okay, did they actually run this thing? You can look in their user Hive, and you can see that the user assist is saying, yep, they ran it, and the last time they ran it was this timestamp. Shimcache and AMCache are useful for finding just if an executable ran. It doesn't always tell you if the user ran it, but very useful for malware as well. And those work, like Shimcache, for example, as we're transitioning from XP to so I need someone to throw something at me. Thank you. Jeez. Sleep, it helps, I swear. The Windows developers basically created this the shim so that just in case if you ran an old XP system or something, just an old piece of software, it could detect if it's going to look for any of the obvious places, like, it remembered that this DLL it's going to load is always in this location. So Microsoft put in this shim piece so that it'd be like, no, it's actually over here. So it would automatically do these things. But by doing that, it actually keeps a running log of every single process that ran. So you can parse that out and see, like, okay, if something ran, I can at least see when it ran. And malware, for example, may do that. I mean, it just will run, and you can find a copy at least of the name and a couple of other good facts. And then if you find something in memory, you can always do a file scan. So you could look around and see any files that are still there, whether it be documents, pictures, or a copy of the malware, for example. And you can dump it to disk and perform more analysis. Shell bags is another one of those user hives type of artifacts. And shell bags is, you open up File Explorer and you sort, by you sort by size or date, or you want your icon sizes a certain size and the way it looks. All that's stored in your registry. And it not only stores that, but it actually stores the path for all these files. So if you go in there and you create a whole bunch of folders and directories, mess around, then you delete stuff and walk away, shell bags may still have a lot of the information. And so you can use that to see if someone may have, gone in, taken a bunch of stuff, and then deleted it, or in general you can see stuff that they were working on. And Timeliner is a big plugin that will do a lot of work automatically for you. So it will take a lot of these artifacts that we kind of talked about, a lot of these plugins and volatility, and basically just dump them out to a big CSV file with a timestamp. So you can just open up Excel, which is still running the world, and you can open up Excel and you can sort by the time fields that this activity was occurring, and it'll give you a bigger picture of a lot of these artifacts instead of having to do them one by one. It does take a long time to run, though. So, now we'll talk about our next example, Phil the admin versus Frank the cat pick stealer. So in this particular example, Phil's an administrator and Frank is just a regular user. But somehow, Frank stole Phil's pictures. So again, one of the first things we'd usually do is an image info to find out what profile we use. In this case, we have a Service Pack 1, and it's Win7, so we're going to go with our Win7 SP1 x64. So the first command that I actually ran, because some of these can take some time, so I preloaded them. Amazing. But this one in particular is we're looking at the Chrome search terms. So these were things that the person was Googling. Things like, can cat shoots an owner with a 9mm, which actually is an article on the internet, what I found. It was very interesting. Can cats own guns? Scary things like that. Then we started to see some other ones that are a little more interesting, like how do I get administrator, or how do I get administrative privileges on Windows 7, how to open PowerShell as an admin, most common admin passwords. So a little more intent of what that person may have been doing on the system. So one thing we noticed was the word PowerShell popped up. So let's go ahead and run that command scan. So this time we get a little bit more data. So we have the user in a command prompt was trying to access the directory users Phil. And then he just started screaming some crap out and said, damn you, Phil. So probably didn't have access. But we can't really tell because command scan doesn't tell us that information. But the next one we have is a PowerShell.exe. And this one looks to be a little more successful. So we have, he's able to access it, looks like it, because he's able to get into pictures, and then his secret cat meme stash. And this plugin is still running. Which means we'll come back to it. There we go. So the other one's running. Let's look at that other one, councils. Councils return us a lot more information. So up here, remember those commands that we ran that we didn't know what they were? Yeah. He tried to get into Phil's directory and the command prompt returned that he had access denied. And he just did some gook, and of course Windows just complains and complained again. But we look in the PowerShell one and we see a little bit more information. We see he was able to not only access the directory, it looks like he opened one, then he copied all these pictures into a new directory in his user directory called, these pictures are mine. And then he deleted them. And then he put a notepad document in there that's FU Phil. What a jerk. So another thing we can do is let's look at that CMD process. Actually, wait, it should be short enough. This PID, we're going to copy the command.exe. And let's run git Bsides. It should tell us the user that was running. Oh, you know what? It may help if you put a P in there. We can see here that it was running as Frank. Now, if we take a look at that PowerShell one, which was 1905, we run the same thing. We see it's running as administrator. So potentially he guessed a default admin cred for the box and was successful. At least that's our running theory. So this was, because IE history takes a little while to run, but we were curious about what Frank was doing. And IE history, and this plugin in particular, you'll see the username gets blacked out when I touch it. But the username starts, and then it shows at file, indicating that that was a file that was opened or manipulated by a person. And we could see some interesting tidbits in here that was stored in his history. We can see that he actually did access the user Phil. He opened up a picture from the secret cache stash. And then also he opened up a bunch of pictures from his new directory that he created on his machine. And then an interesting key is there's a Dropbox. So he was opening these files from his Dropbox as well, which means that he copied these machines, or copied these pictures to his personal Dropbox, and then who knows where it may go. But one other thing we see is that we do see this common admin password list text. So let's see if we can find this text file. It may still be around. Actually, that one is not still around. But earlier, we did see in the command history that the user did create this document, FU Phil. So maybe we can recover that. So we're going to try and run a file scan to see if we can pull down this document. And we're going to grep and just look for FU, something to do on a regular basis. It looks like that file is actually still being retained in memory. So we can do a dump files plugin command on, we can use this physical memory address to pull it down. And then something very useful is always the help. So whenever you're playing around with the plugin, you don't know what you're doing, or you forgot, or you didn't have enough sleep and you forgot, you can always do a -H, and that'll show you the help file, of course, for it. So, and we're looking for -D for this dump directory. And also -Q for the physical memory offset. Anyway, perhaps freaking out again. There we go. So we'll just dump it here. And we'll do -Q. And also there's a command up here, -name. This is rather helpful because it can make it a little more obvious as to what we just pulled down. Is able to pull down, so in the directory, our file's right here. Let's try and open that up. I see the text file he left him was, yeah, these were never meant to be yours, and some little cat ASCII art. So kind of neat. Like you can do quite a bit from memory on a regular basis. Yeah, that's the gist of what I wanted to present today. It is very useful to keep in line with the volatility community. Every year they do a competition for new plugins. Last year was pretty neat because they developed, or someone developed and submitted to the contest a malware framework plugin. So it has a lot of tools that helps you kind of basically hunt for malware within a memory image. There's also some more tools for process hollowing that go beyond kind of what Malfind does as well. So it's very important to, if you're doing a lot of memory forensics, to stay involved with the news and updates and what's going on in the community. But you can get some of that from the volatilityfoundation.org. There's that. Any questions? Yeah. I don't know. Is there something unique that changed? That should be okay. It just sounds like a lot of development work in the future for volatility. Yes. So the document that we found earlier, from what he actually accessed, if you recover that, it actually has a text file that shows what he was actually searching for and which password worked for him. Because he was keeping track in Notepad on his desktop. Yep. So there would be. So the other piece of this is that you could pull out the event logs from the Windows operating system. That would show you the security logs that would have your denies for when he failed and then when he's successful. Yep, with PSScan and PSXView, they're both fantastic for doing that. If the process is trying to hide out of the normal means, like removing itself out of the eProcess block, then you'll pick it up and then you'll find it. So a lot of tools that are stealthy and hide on your operating system, those tools find them in an instant. Not yet. But you're kind of limited in some fashion with those. With Android devices, you can get a lot more. Like you can actually get to the operating system itself. Cellubrite is probably the best tool out there for that. phones, it gets a lot trickier, especially if they're encrypted. Really, the only thing you can go after is usually their iPhone backup, which you can crack into. Yeah, I'm not familiar if there's a project yet for volatility going like memory off of a smart device, but that would be fantastic. The hard part would be how would you get memory off of it, because usually you have to root the devices to be able to get the rights you need to access directly their like memory. But
for the dumping the processes from memory, would that be an effective way to deal with like wireless malware as well?
I guess let's say it one more time.
Where you're using dump the running processes from memory, would that be effective against wireless malware that won't run in memory and doesn't touch it?
Yep. So a really interesting case I had once was a user got infected. Every time they logged in, they had in their NT user their run key. And their run key actually called some VB script. The VB script then called PowerShell. The PowerShell actually pulled out of the registry large chunks of the executable. So it kind of rebuilt the malware directly into memory doing that. And so we then had a PowerShell session running that loaded up shellcode and executed. So all along that path, you can use volatility to dump those, either the process itself, or you can also dump the memory segments and do analysis that way. Yeah. Anything else? Yep. And there are, but they're kind of getting, at least with FireWire I know, they're getting faded out because you can only access the first like 4 gigs of memory. And so you're kind of limited into how much you could pull, especially now that most machines are starting with 8 to 16. But a lot of if you're in an enterprise, majority of the time you're going to be using like an enterprise tool that can do that for you. Yep. Well, sometimes you're admin. It's unique. Yeah, it gets a little trickier when you either have to break into the system, because then you can try and cold boot attack like the memory and like freeze it and then like transfer it over to it. And they actually sell those devices, which I think is great. Whoa! You can actually sell those devices where it's a forensics kit where you're supposed to freeze the memory and transfer it over, and then it'll actually take a copy of the memory right there. So I actually was just having that conversation, and I want to try it. Because another idea was if you're an attacker and you got onto like the root of a VMware server, right? And you dumped the VM's entire memory, which would be gigantic, right? But in theory, you should be able to access the memory of the other running operating systems in there. So I think you might be able to, but I haven't tried it. At least potentially possible. Have you? Cool. Any other questions? Is everybody going to go download volatility tonight? Okay. Thank you. That's all I got.